So number 13, as time t passes, the concentration of organisms in a seawater sample is modeled by the function c of t equals 0.80 times 1.2 to the t. Which of the following statements is supported by the behavior of c of t? So A, according to c of t, the concentration will decrease over time. According B, the concentration will increase over time. C, it will remain the same. And D, no generalizations can be made. So 1.2 is your growth factor, which is greater than 1. Therefore, it's going to grow. So the answer is B, it will increase over time. Now, number 14, which expression is equivalent to the log 4 divided by the log 10? Now, log 7 times log 4, you just have to evaluate in your calculator. You can't say the multiplication is the same as division, so A is not correct. Log 7 plus log 4 is equivalent to the log of 7 over 4, which is not the same as log 4 divided by log 7. Log 4 divided by log 7 is the log of 4 minus the log of 7. So that's not the same thing. Log base 7 of 4, if I use change of base formula, is the log 4 over the log of 7. So far D is correct. And C is, or E would be the log of 7 over 4. Oh wait, I did B wrong here. This is not right. This is times. So that would be 7 times 4. Which would be 28, which is not true. So the answer is D. I apologize. All right, so now we're at number 15, solving equations. The natural log of y plus 7 over 3 equals 4. I have a log equal to a number. I don't need to expand anything. I just need to rewrite it as an exponential, or I need to exponentiate. So natural log is log base e, so that I can rewrite that as e to the 4th power equals what's inside. Oh, let me do that the other way around. Oh, you can't find my eraser. Y plus 7 over 3 is equal to e to the 4th. I'm trying to stay consistent in keeping my variables on the same side of the equal sign. Now we'll times by 3. So we get y plus 7 equals 3e to the 4th and minus 7. Y equals 3e to the 4th minus 7. So if this is on the no calculator portion, it shouldn't deter you from doing the log problems. But if it's on the calculator portion, you can plug it in and round to the nearest hundredth. We get e to the 4th times 3 minus 7. And y is approximately 156.79. We should really be using the squiggly equal sign because it's an approximation. The exact answer is 3e to the 4th minus 7. Number 16, I have e to the x over 5 plus 4. I need to get the e by itself, so I'm going to subtract 4. So e to the x over 5 equals 3. Rewrite it. X over 5 equals the natural log of 3, using the same skill we used in the first set of the problems from this worksheet. You could also natural log both sides and end up with the same answer, times by 5. And it's x equals 5 natural log of 3. You can't multiply that 5 to the 3 because the 3 is inside the log. So you're not allowed to distribute or multiply inside there. And now I can do it in my calculator. 3 natural log. I'm using my cell phone, so it's got to go backwards. And x is equal to 5.49. Number 17, e to the k equals 18. So I'll show this one using the natural log of both sides. Natural log of e to the k equals natural log of 18. And the natural log of e to the k is just k. K equals the natural log of 18. 18 natural log. K is approximately, I messed up there, didn't use approximately on the last one, 2.89. And number 18, we're going to condense this first because I have two logs on the same side, natural logs. My 3 becomes my exponent, so the natural log of x minus the natural log of 3 cubed equals 3. And subtraction becomes division. I saw a lot of mistakes today on this. It's the natural log of x over 3 cubed. When I'm condensing, there's only one log in the condensed form, equals 3. And I can exponentiate. We'll do that, e and e. And so e to the ln x over 3 cubed, which is 27, is x over 27 equals e cubed times by 27. So x equals 27e cubed. And to get my approximation, I do it in the calculator. I get x is approximately 542.31. Number 19, log base 9 of 3u plus 14 minus log base 9 of 5 equals log base 9 of 2u. So I have more than one log on one side of the equal sign here, so I have to condense it. And subtraction becomes division, so it's the log base 9 of 3u plus 15 divided by 5 equals the log 9 of 2u. One log when it's condensed. I should not have the word log written more than once. It's not this log divided by another log. It's the log of the quotient of what's inside. So now I have two logs 9s, so I can just equate what's inside. 3u plus 15 over 5 equals 2u. Multiply both sides by 5. And you get 3u plus 15. I'm seeing a lot of mistakes on this too. A lot of people are distributing the 5 to the numerator. You're multiplying by 5 over 1 so that the 5 cancels the denominator and you get what's on the numerator. You do not distribute because then you're multiplying by 5 over 5, which is 1, and that doesn't get rid of your fraction. So that equals 10u. Subtract your 3u. So 15 equals, oh, this somehow morphed to a 15. Sorry. Let's fix that. This will work out nicer for us. 14. So 14 equals 7u, and divide by 7, and u equals 2. Number 20, log base 4 of x equals 1/2. So I can rewrite this. 4 to the 1/2 power equals x. 4 to the 1/2 power is the square root of 4, so x equals 2. Number 21. 21 is the long one. I'm going to clear off the rest of this screen because I think I'm going to need it. We're going to take the log of both sides. The log of 6 to the 3y equals the log of 8 to the y minus 1. Now another option is to take the log base 6 of 6 to the 3y equals the log base 6 of 8 to the y minus 1. I'm going to show you both methods. Both answers are correct. You'll notice in our solutions that we do it a little bit differently by getting a decimal first, and that's not how we're showing you to do it this year because we want to make sure you can write it in the exact answer form. So we're going to move our exponent out front here. 3y log 6 equals y minus 1 log of 8. 3, why did I do that? Gosh, move that back up. There we go. That's 3y log of 6 equals y log of 8 minus the log of 8. I'm going to subtract my y so I get them all on the same side because I can't write my answer with a y in it. We can't say y equals something y. Minus y log 8. So these cancel on that side. I get negative log of 8 and 3y log 6 minus y log of 8. I can factor out my y and I get 3 log of 6 minus log of 8 equals negative log of 8. And now we will divide by 3 log of 6 minus log of 8. Divide by 3 log 6 minus log of 8. And our answer, y equals negative log of 8 divided by 3 log 6 minus log 8. And then we got to figure out what this is in the calculator. I'm going to do it by evaluating the numerator first, writing that down, and then evaluating the denominator, and I may even have to do that in pieces. So I have the log of 8, which is 0.9, so negative 0.9 in my numerator, divided by 3, let's see, log of 6 times 3 equals that minus the 0.9, and I get 1.43, so 0.9 divided by 1.43 is, and it's negative, so approximately negative 0.629. And that's my approximation. Now let's look at the other method of doing this problem. What if we did log 6 instead? You could even do log of 8 if you wanted to, or log base 8. So here on the left side, log 6 of 6 to the 3y is just 3y. And that is equal to y minus 1 times the log 6 of 8. And then we're going to distribute. Y times the log 6 of 8 minus the log 6 of 8. And then minus y log 6 of 8. So I get 3y minus y log 6 of 8 equals negative log 6 of 8. Take out the y, 3 minus log 6 of 8 equals negative log 6 of 8. Divide by 3 minus log 6 of 8. And then I got to plug it into my calculator. Negative log 6 of 8 divided by 3 minus the log 6 of 8. And when I do that in my calculator, I should get the same answer. The difficult part about this method is the actual plugging it into the calculator part, because you have to use your change of base formula. I have to use the negative log of 8 divided by the log of 6 to get the numerator, and then I have to use that again. So 8 log divided by 6 log, enter, I get 1.16. So my numerator is negative 1.161. And then my denominator is 3 minus 1.161. And that's 1.839. And then 0.161 divided by 1.839 gives me 0.631, which is close enough because I rounded that answer. So I got approximately 0.631, which is only off by 2 thousandths places, and that's because I rounded both of those answers. Okay, so if you're still copying, you're going to need to pause it because I'm moving this out of the way so I can do this last problem. 2 to the x equals 53. Let's see, let's do the log base 2 of both sides of 2 to the x equals the log base 2 of 53. So x equals the log base 2 of 53. And then to do that in my calculator, log of 53 divided by the log of 2. And I get x is approximately 5.728. And it looks about right because 53 is between 32 and 64, which is 2 to the 5th and 2 to the 6th power. So that's one way you can kind of see if it's about right and you plugged it in correctly. All right, number 23, 3 times the log base 5 of x squared plus 9 minus 6 equals 0. So the first thing we have to do is get the log 5 by itself. So I'm going to add 6. 3 log 5 of x squared plus 9 equals 6. Get the 3 out of the way, divide by 3. Log base 5, that looks like logs of x squared plus 9 equals 2. And we write this 5 squared. So that's one option. So 5 squared equals x squared plus 9. Now, if you're not getting that right, you need to exponentiate both sides by putting the 5 underneath it as the exponent. So an exponentiating would look like this, 5 to the log 5 of x squared plus 9 equals 5 squared. And the 5 log 5 cancel, and you get x plus 9 equals 5 squared. You get the same thing. So subtract the 9, and x squared equals 16 because this 5 squared is 25, minus 9 is 16, and x equals plus or minus 4, because I take the square root of both sides. I need the plus or minus. Am I allowed to have both? That's a good question here. When I plug in negative 4, does it make the of part of the log negative? Nope, because I'm going to square it first. And then does it make the positive 4? Does that make it negative? No. So this is one of those cases where both the positive and the negative are acceptable answers. Number 24, log base 7 of n plus 8 is less than log base 7 of 3n. I have the logs on both sides, so I can just equate what's inside. N plus 8 is less than 3n. I'm going to subtract my n's, and 8 is less than 2n, so 4 is less than n, which means n is greater than 4. And look at your domain restriction, n plus 8 has to be greater than 0, so n has to be greater than negative 8. So we don't have to worry about putting a second restriction on it because all of our answers, n greater than 4, are greater than that negative 8. And number 25, log base 3 of k minus 2 is less than or equal to 4. I'm going to use exponentiating on this, make it 3 to that power and 3 to the 4th power. And when I do that, log 3 of k minus 2 is just k minus 2, less than 81. Add 2 to both sides, and k is less than 83. And then k minus 2 has to be greater than 0. So add 2 to both sides. K has to be greater than 2. So my inequality is 2 less than k less than 83. Okay, graph each function, draw the asymptote with dashed lines, write the equation of the asymptote, state the domain and range. So we're going to start with number 26. 26 is y equals 2 to the x plus 3. So I'm going to graph my parent function, 2 to the x. Negative 1, 0, and 1. 2 to the negative 1 power is 1/2. 2 to the 0 power is 1. Anything to the 0 power is 1. 2 to the 1 power is 2. So I'm going to draw that, and this is just a parent graph here. Put those points on. Let's do it in a different color here. This is just my parent function, remember? Okay, and now all of those points move up 3 because that's my transformation. So we'll do that in blue. We'll go up 3. So 1, 2, 3. That's going to be at 5, 4, 4.5. So my asymptote, this is really driving me crazy today. I can't write with this pen. My asymptote is the equation y equals 3. Y equals k, always. So then draw that dashed line. And then connect my line. My domain is x such that x is all real numbers contained in the set of all real numbers. My range is y is greater than 3 because it's all greater than my asymptote. Number 27, y equals 1/3 to the x. My parent graph is 1/3 to the x power. Plug in -1, 0, and 1. That's 3, 1, and 1/3 because 1/3 to the -1 power is the reciprocal. And we'll draw that. So and then all of my points move down 3. So I'm going to move my points down 3. Let's see. We are at 1/2. So we're going to go to 1, 2, 3. Oh, sorry. No, it's just down 2. Thinking of the last problem. And then down 2 and down 2. My asymptote is at -2. So my asymptote is y equals -2. Connect my points here. And my domain, x such that x is contained in the set of all real numbers. And my range, y is greater than -2. And last problem, 28. My parent graph is log 2 of x, and then we're going to move right 2. So remember this one, we use -1, 0, and 1 as our y values, and we ask ourselves, log 2 of what equals -1? Well, log 2 of 1/2 equals -1. Log 2 of what equals 0? Log 2 of 1 equals 0. Log 2 of what equals 1? Log 2 of 2 equals 1. So when I graph this one, I have at 1/2 -1, 0, 1, and 1, 0, and 2, 1. And this graph, this is the parent, looks like that. It has a vertical asymptote. All these points are going to move right 2, so we'll do that in blue. Right 2, right 2, and right 2. My asymptote is going to be the vertical line where x equals 2, and connect my points. My domain is x is greater than 2. It's not equal to because it doesn't touch it. And my range is y is contained in the set of all real numbers.